A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com.
Hi Herman and Corn. I want to ask today a couple of very specific questions about building agentic AI tools that I think, having been experimenting with these for, probably a year at this point, there's still kind of these unresolved open loops for me. And I think a lot of people are in a similar position where we're building out these things and we're all just trying to we're all just figuring out as we go along what's the best way to do something. And the challenge of AI and the beauty of AI is that it's so new that there often isn't one prescriptive way to do things, which is both exciting because you really feel like you're at the frontier of creating something new, and limiting because, unlike, let's say, how to deploy a Postgres database, there isn't that clean and polished. Here's how to do it. This is what we've agreed upon. There are other methods. This is the standard one. Great. So it's kind of hacky. Now, one of the things when I built agents, and I'm going to use a simple example for an agent that is something I've definitely prototyped, and I'm using this because it touches upon a few different requirements. Let's say I want to build an AI agent that is a parenting advice agent, right? As you guys know, I have a 9-month-old who I'm holding in my hands currently, in my arms, as we pace around the kitchen, don't we, Ezra? He likes that. And that was one of the first things to me. It's great. I'd love to, I think like every parent, we feel like we're kind of making it up as we go along. I watch resources, but sometimes for quick questions, especially when your hands are tied up, a voice agent, very useful. Now, one layer of the AI experience that I like to weave in and is context. By context, I mean not the context window, right? We talk a lot about how many tokens an AI can hold in its state memory as you go through a conversation. I'm talking about context in the colloquial sense of the term, by which I mean the foundational details that agent will need to know in order to be useful. My name is Daniel. I'm going to be using you to talk about my son, Ezra. We live in Jerusalem, and maybe a few other light details. It's very light, and the question that I always have is, we're going to talk about more advanced things like RAG and memory in the next couple of episodes, which I'm going to send in after this one. But this is kind of a hard one to pin down because it's so sparse that you wouldn't set up a vector database to hold 3 sentences of text, and yet a system prompt, if we're going to be finicky about it, is really trying to determine the model and functionality or give a guidance on that, not necessarily to front load information. But this type of information, the context, the idea is indeed that it should be front loaded. It should be there every time that you send a prompt. You don't have to repeat those foundational details or you'll go crazy. And my method is probably system prompting, but sometimes I'll create a lot more elaborate set of instructions, and then the system prompt will become this kind of clunky, large prompt that I feel like, why am I trying to stuff memory and context data into a system prompt? This is the wrong place for it. So that's where I'd love to start with our agentic engineering conversation, talking about the little nuts and bolts, because I feel like we're sitting on fantastic AI models. Gemini 3.1 Lite is the one I'm currently using the most. I also use Gemini 3.1 Flash. Lite one is just the more cost-effective one, but they're both really affordable and they're both fantastic in the open source world. Mistral, OpenAI, and I feel like where we are with AI at the moment to create these great experiences that are really useful for getting AI to do things. We need MCP, but we also need these other little pieces of the puzzle. Those system instructions, the memory, the context, however you choose to define that, and we'll talk about those in forthcoming episodes. But today, let's talk about creating that baseline of foundational background information for an AI tool. What's the best way to go about doing it? What are some of the pros and cons of the various ways one could implement it, whether you're building a chatbot or a voice agent or some other interactive AI experience?
You ever find yourself pacing the kitchen at 3 in the morning, one arm occupied by a tiny human who refuses to acknowledge the concept of sleep, trying to Google how to soothe a teething 9-month-old with your one free thumb? It is the ultimate stress test for user interface design.
It really is. The physical constraints of parenting are basically the extreme environment that engineers should be testing every consumer product in. If you can't use it while sleep-deprived and one-handed, is it even a finished product?
And today's prompt from Daniel hits on that exact scenario. He's been working on a parenting advice agent, specifically a voice-based one, because when you're Daniel, pacing around in Jerusalem with young Ezra, you don't have a spare hand for a keyboard. But he's running into a classic engineering headache, the who am I problem. He doesn't want to tell the AI his name is Daniel and his son is Ezra every single time he asks a question.
It's the colloquial context problem. By the way, I should mention, today's episode is powered by Google Gemini 3 Flash. Fitting, since Daniel mentioned he's been leaning on the Flash models for their speed and cost effectiveness. But back to the context issue. We aren't talking about a massive database of documents here. We're talking about 3 or 4 sentences of foundational identity that make the AI actually useful. I'm Herman Poppleberry, and today we are digging into the nuts and bolts of how you actually store those small, persistent details without making your code a complete mess.
It feels like such a tiny problem on the surface, right? It's just a few strings of text. But as Daniel pointed out, we don't have a standardized way to do this yet. In the old world, you just throw it in a user profile column in a database. In the AI world, you have to decide exactly how and when to whisper that information into the model's ear so it doesn't forget who it's talking to.
And that's the tension. Do you stuff it into the system prompt? Do you tack it onto every message? Or do you build a tiny little sidecar database just for Daniel's life facts? Each one of those has a trade-off that affects latency, cost, and how smart the agent actually feels.
Let's start with what Daniel called the clunky method, the fat system prompt. This is where you just take your instructions, like you are a helpful parenting assistant, and then you just keep typing. The user is Daniel, his son is Ezra. Ezra is 9 months old. They live in Jerusalem. Daniel likes evidence-based medical advice, but also traditional Irish lullabies. Eventually, your system instructions look like a biography.
The fat system prompt is the lazy developer default, and I say that with affection because I do it all the time. The upside is zero infrastructure. You don't need a database, you don't need a lookup step, it's just one big string sent to the API. But the downside is what I call instruction dilution. When you mix who the user is with how the AI should behave, the model starts to get confused about priorities.
Is that still a big issue? I mean, with Gemini 1.5 Flash, especially the updates from January 2026, the instruction following is significantly better. Can't these models handle a few extra sentences of bio without losing the plot?
They can handle it better than they used to, but you're still wasting tokens. Think about it. If you have 100 users, and each one has a slightly different fat system prompt, you can't cache that system prompt as effectively. You're paying to send those same biographical details over and over again in the instruction block, which is usually weighted differently by the model's attention mechanism than the actual conversation.
Plus, it's just bad data hygiene. If Ezra turns 10 months old, which, spoiler alert for Daniel, happens surprisingly fast, you have to go into your code or your prompt management system and manually edit the instructions for that specific user. That doesn't scale. It's like hard coding your grocery list into the source code of your fridge.
That's a great way to put it, and there's a psychological component for the model too. If the system prompt says, "You are an expert at Jerusalem-based parenting," the model might start hallucinating that it only knows about Jerusalem, even when Daniel asks a general question about sleep cycles. It narrows the persona in ways you might not intend.
So, if the system prompt is the wrong bucket, what about the pre-pending method? This is where the system prompt stays clean, just the rules of the road. But every time the user sends a message, the app secretly tacks the context onto the front. Like Daniel says, what's a good breakfast for a 9-month-old? And the backend turns that into context. User is Daniel, son is Ezra, 9 months. Question, what's a good breakfast?
This is actually what a lot of production agents do in the early stages. The pro here is that it's model agnostic. You can swap from Gemini to Mistral to OpenAI, and your context injection logic stays exactly the same. It's explicit. The model sees the context right before the question, so it's very high in the priority list of the context window.
But isn't that even more token heavy? If I have a 20 message back and forth, am I sending Ezra is 9 months old 20 times?
It's redundant. If you're using a model with a huge context window, you're basically paying a context tax on every single turn of the conversation. And if you're building a voice agent like Daniel's, latency is king. If your prompt gets 20% longer because of injected context, the time to first token might crawl up just enough to make the conversation feel laggy. When you're holding a crying baby, a 3-second delay feels like an eternity.
I've noticed that with voice agents. If there's even a beat of silence after you finish talking, you start wondering if the app crashed. It ruins the illusion of agentic behavior. It just feels like a slow computer. So, if we hate the fat system prompt for being messy, and we hate prepending for being expensive and slow, what's the engineer's choice?
The middle ground is a lightweight key value store. We're talking about something as simple as a JSON file or a SQLite database. Instead of trying to force the LLM to remember these facts through the prompt, you treat the facts as data that gets pulled in only when needed.
But Daniel's point was that he doesn't want to set up a whole vector database for 3 sentences. Is SQLite overkill for just knowing a kid's name?
Not at all. In 2026, running a local SQLite instance is practically free in terms of overhead. The beauty of a key value store is that it separates identity from logic. You have a table for user context. When Daniel starts a session, the app pulls Daniel, Ezra, 9 months Jerusalem into a local variable.
Okay, but you still have to put that variable somewheres in the prompt to make the AI aware of it. Aren't we back to square one? Whether it comes from a database or a hard-coded string, it still has to enter the LLM's brain.
Not necessarily. This is where the agentic part comes in. If you're using a framework like LangGraph or Crew AI, or even just a well-structured tool calling setup, you don't have to give the LLM the context up front. You give the LLM a tool called getUserContext.
Oh, I like that. So the AI starts the conversation with a clean slate. Daniel says he won't stop crying, and the AI thinks, wait, I don't know who he is or how old he is. Let me check the user context tool. It hits the SQLite database, sees Ezra, 9 months, and then responds with, since Ezra is 9 months, it could be teething.
That is the clean way to build an agent. It keeps the context window lean. It only pulls the data when it's actually relevant. If Daniel asks a question about the weather in Tel Aviv, the agent doesn't need to waste tokens thinking about Ezra's age. It only invokes the memory when there's a missing variable in the user's request.
That feels much more like how a human brain works. I don't walk around constantly reciting my brother's age and address in my head. I only pull that info up when I'm buying you a birthday card or calling you an Uber. But let's talk about the parenting in the kitchen test. If the agent has to think about calling a tool, then call the tool, then get the result, then generate an answer, isn't that slower than just having the text already there in the prompt?
It's a trade-off. Tool calling adds a round trip, but with Gemini 3 Flash, that round trip is incredibly fast. We're talking milliseconds. The real benefit is the reliability. When you explicitly pull context from a data store, you're less likely to get hallucinated context.
I've seen that happen. You tell an AI too much about yourself in the system prompt, and it starts assuming everything you say is related to that. You ask, what's the capital of France? And it says, the capital of France is Paris, which is a great place to take a 9-month-old like Ezra. It becomes that annoying friend who can only talk about one thing.
We call that attention drift. The model's attention mechanism gets so saturated with the foundational context that it starts to bleed into the actual task. By moving that context into a sidecar database and using tool calling or a retrieval on start pattern, you keep the conversational lane clear.
Let's look at the retrieval on start pattern. That sounds like a hybrid. When the voice app wakes up, it does one quick fetch to the database. Who is this? It gets the bio, and then it populates the session memory. So for the rest of that specific kitchen pacing session, the info is in the context window, but it's not hard-coded into the system.
You treat it as ephemeral session memory derived from persistent data. When the session ends, the context window is wiped. If Ezra has a birthday tomorrow, you update the SQLite database once, and the next time the agent wakes up, it pulls the new age. No prompt engineering required.
This seems especially important for the multi-user scenario Daniel mentioned. If you're building a startup, you can't have 1,000 different system prompts. You have one system prompt that says, "You are a parenting expert. Use the provided context to tailor your advice." Then your backend handles the injection of Daniel's specific life or Herman's specific life.
And that's where the colloquial context becomes an engineering asset rather than a chore. If you store it as structured data like a JSON object with keys for username, child name, location, you can actually do logic on it before it even hits the AI. You could have a bit of code that calculates Ezra's age in weeks automatically. The LLM doesn't have to do math, which it historically may at it, just receives the current accurate facts.
Historically meh is a very polite way of saying LLMs used to think 9 months plus 1 month equals 11. They've gotten better, but your point stands. Don't make the AI do work that a 3-line Python script can do perfectly every time.
Right, so for Daniel pacing the kitchen, the pro move isn't a better prompt, it's a better orchestration layer. He mentioned Gumloop and LangGraph. Those tools are designed for exactly this. You create a pre-flight node in your workflow. Step 1, fetch user bio. Step 2, check for recent events. Step 3, send to LLM.
I want to push back on the don't use a vector database thing for a second. I know Daniel said it's overkill for 3 sentences, but what if those 3 sentences grow? Today it's Ezra is 9 months. In 6 months it's Ezra likes blueberries, he's allergic to peanuts, he's hitting his crawling milestones. Suddenly, your foundational context is a whole page of text. Does the SQLite key value store still hold up?
It does, because you can still use basic keyword search. You don't need semantic vector embeddings to find a peanut allergy. You just need a table of facts. If the user mentions food, you query the facts table for anything tagged food or allergy. It's RAG-lite.
RAG-lite. I like that. It's like the diet soda of AI architectures. All the flavor of retrieval, none of the I have to manage a pinecone index calories.
Precisely. And for a voice agent, that simplicity is your best friend. Every layer of complexity you add, vector databases, embedding models, semantic re-rankers, is another place for the system to break or lag. If Daniel is asking the agent, can he have honey yet, he needs an answer now. He doesn't need a semantic search of his entire life history, he just needs the age variable and the medical preferences variable.
It's funny, the more we talk about agentic tools, the more it sounds like traditional software engineering. It's about state management. We spent the last 3 years obsessing over prompts, but in 2026, the prompt is just the UI for the model. The real engine is how you manage the data flowing into that UI.
That's the shift. We're moving from prompt engineering to context orchestration. Daniel's frustration with the clunky system prompt is a sign that he's outgrown the chatbot phase and moved into the agent phase. A chatbot listens and responds. An agent knows quo and acts. And knowing requires a stable place to keep its knowledge that isn't just a giant messy paragraph of text.
Let's talk about the voice. Specific constraints of this. When you're using a voice interface, you don't have a chat history. You can scroll back through to see where the AI got confused. If the agent forgets Ezra's name halfway through a conversation, it feels like a personal betrayal.
It breaks the social contract. If I'm talking to a human about my kid, and 5 minutes later they say, "So, how is your daughter doing?" I'm immediately checking out of that conversation. With AI, that betrayal happens because of context window truncation. The conversation gets too long, the oldest messages, the ones where you said, "My son Ezra," get pushed out of the window, and the AI loses its foundational context.
And that's the strongest argument for the sidecar database, or tool calling approach. If the info is in the system prompt or a prepended block, it's at risk of being ignored or diluted in a long conversation. If it's a tool, The agent can call. It's always available, no matter how long the transcript gets.
It's like giving the AI a permanent cheat sheet it can glance at whenever it needs to. Oh, right, Ezra. 9 months. Jerusalem. It makes the agent feel much more stable and present.
So, if we're giving Daniel a to-do list for his parenting agent, where does he start? He's already got the prototype. He's using Gemini 3 Flash. He's got the basic logic. How does he transition from clunky prompt to elegant agent?
Step 1. Strip the bio out of the system prompt. Keep the system prompt focused entirely on how to speak. You are a concise, evidence-based parenting assistant. Use the provided tools to verify child age and medical history before giving safety advice.
Step 2. Set up the identity store. If he's building this in a tool like Gumloop or a custom Python script, just use a simple JSON object or a SQLite row.
Right? And step 3, the injection strategy. For his specific one-user case, the prepended context actually isn't a bad move if he wants to stay low code. Just have the app start every prompt with current context, JSON object. It's a bit of a token waste, but for a personal project, it's the most reliable way to ensure the model never forgets the basics.
But if he wants to go pro, he should look at the injected system instruction feature that models like Gemini have been leaning into. You can actually update the system instructions mid-conversation now. So when the app starts, it fetches the bio and sets that as the system instruction for the session. It's cleaner than prepending it to every message.
That's a great point. It keeps the user message lane purely for Daniel's questions. It separates the facts into the instruction layer, where the model's attention is more focused on the rules of engagement.
I think there's also a takeaway here for people who aren't building parenting agents. This problem of sparse foundational context is everywhere. It's in coding assistants who need to know your preferred libraries. It's in travel agents who need to know your frequent flyer number. It's the small data problem of AI.
We've spent so much time on big data RAG with millions of documents that we forgot how to handle small data. But for a truly personal agent, the small data is actually more important. The fact that my son is allergic to peanuts is a small data point, but it's more critical than any big data medical journal entry about peanut allergies in general.
It's the difference between knowledge and context. Knowledge is knowing that babies shouldn't have honey. Context is knowing that there is a specific baby in the room right now who is under 1 year old. Without the context, the knowledge is just a textbook.
And that's the goal of agentic engineering. We're trying to build textbooks that know who's reading them. Daniel's approach using those lightweight models like Flash is exactly right because it gives you the headroom to do these extra context management steps without breaking the bank or waiting 5 seconds for a response.
It's also worth noting that as these models get cheaper, and they are getting insanely cheap, the token tax of sending a bit of extra context matters less and less. We're moving into an era of token abundance. So if you're a developer and you're stressed about wasting 50 tokens on a bio, maybe just let it go. The user experience is worth more than the fraction of a cent you're saving.
Token abundance is a dangerous drug, Corn. That's how you end up with messy, inefficient agents. I still think the discipline of context orchestration is worth it. Even if tokens are free, the contentions of the model is finite. The more junk you put in the prompt, the less the model focuses on the core question.
Fair point. You can have an infinite context window, but you don't have infinite reasoning power to apply to that window. The lost in the middle phenomenon, where models forget things buried in the center of a long prompt, is still a reality, even in 2026.
It is. So keep the foundational context at the very top or the very bottom. Or, better yet, keep it in a structured block that the model recognizes as the facts.
One last thing on the voice front. Daniel mentioned the hands-tied scenario. One thing I found useful in those agents is a context confirmation step. Every once in a while, the agent should say, "Just to confirm, we're still talking about Ezra, who's 9 months now, right?" It's a way for the agent to save its state and for the user to correct it if the small data has changed.
That's brilliant. It turns state management into a conversational feature. Hey, I noticed it's been a month since we talked. Is Ezra 10 months old now? It makes the agent feel like it's growing with the family. It moves from tool to companion.
And that's the weird prompt dream, isn't it? An AI that doesn't just answer questions, but actually understands the life it's inhabiting. Whether you're in Jerusalem or anywhere else, having a parenting agent that knows your kid's name isn't just a convenience. It's a way to feel a little less alone in that 3 a.m. kitchen pacing.
It's about reducing the cognitive load of the interface. When you're stressed, you don't want to interface with a computer, you want to talk to something that already understands the situation.
Well, I think we've given Daniel enough architectural homework to keep him busy while Ezra naps. We've covered the fat system prompt trap, the prepending tax, and the SQLite sidecar solution.
And the most important takeaway, don't over-engineer the small data. If a JSON file works, use a JSON file. You don't need a spaceship to cross the street.
Unless the spaceship is really fast and has a built-in bottle warmer. Then I might consider it.
Always looking for the gadgets. Corn.
Guilty. But seriously, this is the frontier. We're all just figure out how to weave these models into our actual messy lives. Thanks to Daniel for the prompt. It's a perfect example of a real-world AI problem that doesn't have a standardized answer yet.
It's the hacker's frontier. And honestly, that's the most exciting place to be.
Before we wrap up, I want to say thanks to our producer, Hilbert Flumingtob, for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power this show and our research. They make it possible for us to dive deep into these models and figure out what actually works.
This has been My Weird Prompts. If you're finding these deep dives useful, or if you built your own small data solution for an agent, we want to hear about it. Drop us a review on your favorite podcast app. It really does help other agentic engineers find the show.
We'll be back next time to talk more about the next layers of this puzzle, RAG and long-term memory. But for now, get those SQLite databases ready.
And good luck in the kitchen, Daniel. We're rooting for Ezra to get some sleep.
See ya. See ya.
Bye. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from sloth